to examine the development, the challenges, and explore the critical role of demand flexibility in ensuring an affordable, sustainable, and efficient electricity market. Capacity mechanisms are financial tools designed to ensure a sufficient energy capacity. They provide extra payments to prevent market exit or to encourage investment in new capacity. Capacity payments are typically arranged through long-term contracts for the availability of capacity. System adequacy is a prerequisite for capacity mechanisms and measured for specific methodologies approved by ACER, developed and conducted by NSOE. Also, national subsequent studies are possible. EU electricity markets initially operated as energy-only markets, paying solely for energy delivered. However, concerns about security of supply and market imperfections led to the development of capacity mechanisms at national level. These concerns grew with the phase-out of nuclear production, highlighting resource adequacy issues, which refer to the system's ability to maintain a stable frequency of 50 Hz, ensuring that supply meets demand always. Capacity mechanism address these concerns by providing long-term solutions to balance demand and supply, preventing forced consumer disconnections like rolling blackouts or load shedding. They ensure sufficient reliability resources, facilitate investment in new capacity, prevent market exit, and include measures to reduce consumption or enhance storage. However, this approach has been heavily debated in research as well as in industry. Capacity mechanism in the EU is based on a two-pillar system rooted in primary energy law. Article 194 of the Lisbon Treaty grants member states the right to determine their own security of supply levels, while Article 107 prohibits state aid unless justified. Secondary law reaffirms member states' autonomy and establishes harmonized definitions, methodologies, and coordinated EU-wide processes to measure adequacy. In Norway, competition law and state aid regulation are applicable, but the clean energy package is not, due to the EEA backlog. This regulatory difference may impact Norway's relationship with Sweden, particularly participation in Sweden's planned new market-wide capacity mechanisms. Norwegian market players will need to consider how these regulatory frameworks influence their ability to engage in the Swedish capacity mechanism and the potential effects on cross-border electricity trade. This slide illustrates the current status of capacity mechanisms across European countries, highlighting which nations have implemented them and the various categories of capacity mechanisms. Strategic reserves, paying certain producers to avoid market exit while not participating in the regular electricity markets. Although this has been the preferred legal solutions, countries like Germany and Sweden are moving away from it. If we look at cost and trends, the right picture, in 2023, the cost of capacity mechanism in the EU was 7.4 billion euros, representing a 40% increase from previous years. Also looking at ACER's assessment, it's notably that 85% of capacity mechanism payments for 2035 deliveries were allocated to fossil fuel resources. This slide illustrates the development of capacity mechanisms across the EU and how different technologies are benefiting from capacity mechanism payments. Overall, capacity payments have increased across all technologies. Following the introduction of new state aid legislation in 2022, there has been only marginal increase in capacity payments, with a possible focus on enhancing demand flexibility and storage. Possibly this is reflecting that there is more storage in the system. The future of capacity mechanism is uncertain. While Europe is now preparing for a war economy, it is difficult to predict how capacity mechanisms will evolve under these conditions. Electricity markets, where generators obtain revenues only from selling electricity, balancing power, and providing ancillary services, have been termed energy-only market in economic literature. In such markets, generators make investment decisions based on their expectation of future earnings obtained exclusively from these revenue streams. This was the initial theoretical design of the EU market. However, this theoretically perfect market design introduces risk of market clearing prices, the so-called value of lost load, which are politically unacceptable and potentially also disruptive for other reasons. Consequently, many member states did not rely solely on energy-only markets. In addition to renewable support schemes aimed at achieving climate goals, capacity mechanisms have incrementally developed to address the adequacy issues across Europe. On December 2nd, 2024 at 4 o'clock, Europe experienced significant price variations in the energy market, as you see on the left-hand slide or picture. While such price spikes can indicate potential adequacy issues within the energy system, they do not necessarily reflect a structural adequacy problem. Under EU law, addressing these price variations with capacity mechanisms is only legitimate if they are indicative of a structural adequacy issues. Without this justification, the use of capacity mechanism to address price variations is not allowed. Capacity mechanisms were initially introduced as temporary and last resort measures to ensure the security of supply. Over the past decades, they have become more widespread as member states implement mechanisms to address specific national adequacy concerns. Initially, they were not considered state aid. However, with the introduction of the state aid guidelines in 2014, they became classified as state aid. The Commission's sectory inquiry, published in November 30th, 2016, highlighted the necessity of capacity mechanisms and provided guidelines to ensure they are not only introduced when necessary and in a way that minimize market distortions, referencing the state aid guidelines. The Clean Energy Package in 2019 introduced stricter rules and guidelines to ensure harmonized methodologies for addressing the adequacy concerns and for introducing capacity mechanisms. It also emphasized the importance of cross-border participation to enhance the efficiency and reliability of the electricity market. With a recent amendment in 2024, capacity mechanisms have moved to become an ordinary part of the EU market design. This is likely due to the very complex approval process required to obtain exemptions for capacity mechanisms under the 2019 electricity package. Capacity mechanism can cause market distortions by leading to overcapacity, unaffordability, and inefficient outcomes due to additional payments to certain power plants. They may also create state aid and competition issues by favoring specific technologies or companies, resulting in market imbalances. National capacity mechanisms can pose cross-border challenges, creating barriers to trade and distorting market integration, reducing the overall efficiency. Additionally, an insufficient focus on demand flexibility can lead to an over-reliance on supply-side solutions, undermining overall efficiency, environmental goals, and the resilience of the electricity system. Sweden has initiated a process to transition from strategic reserves to market-wide capacity mechanisms. This shift aims to enhance the resource adequacy challenges in Sweden to ensure reliable electricity supply. Norway, which does not have capacity mechanisms, may experience market distortions similar to those between Belgium and the Netherlands, as will be further explained. This picture is to illustrate the timelines for Swedish market-wide capacity mechanisms. As illustrated, both the development and the implementation takes a long time. However, the Commission has come out now with a new guideline where this long time frame can be shortened. Sweden plans to use reliability options as the primary mechanisms, financed by balancing responsible parties, the so-called BRPs. This mechanism can operate on a pay-as-bid or pay-as-clear basis. That's not clear. Norwegian market players may be eligible to participate in Sweden's capacity mechanism, but depending on cross-border arrangements aligning with the EU target model developed by NSOE and approved by ACER. The impact on Norway. The prices and security of supply will depend on the Norwegian market players' participation in the Swedish auction, also with variations across different bidding zones. Sweden faces the biggest challenges in SE3 and SE4 next to NO1, as you can see in the picture. Research indicates potential adequacy issues in neighboring countries, which could affect Norway. Price impacts in the electricity market for both Sweden and Norway will depend on factors like the amount of capacity produced and the pricing of the reliability options. The Belgian capacity mechanism, for comparison, was the first to be approved by the European Commission under the current state aid guidelines in September 2023. This complex structure aims to ensure the security of electricity supply with a budget of 4 billion euros running until October 2031. The Belgian capacity mechanism, organized by Belgian authorities in a particular law and controlled by CREG, the National Regulatory Authority, uses reliability options. Elia, the Belgian TSO, acts as the operator and counterparty in the capacity mechanism contract. The mechanism is open to all technologies, including electricity generation, flexibility, and storage. Pre-qualification is compulsory for producers with more than 1 megawatt capacity and optional for everyone else. The bidding process is based on a predetermined demand curve. Funded by a charge on electricity consumers collected by Elia, the TSO, capacity providers receive monthly premium for their available capacity. Providers must pay back if market prices exceed the strike price of the reliability option and faces penalty for non-availability during the delivery period. Neighboring market players can participate in Belgian auctions, potentially impacting their domestic markets. Capacity providers are selected through competitive bidding processes on the lowest aid per megawatt of capacity. The impact on neighbouring markets will be further explained. This picture is from the consultation. So TenneT, the Dutch TSOs, foresees market distortions due to capacity mechanisms. In the Dutch market, participants must decouple from the Netherlands to be available in Belgium, as the Netherlands lacks a capacity mechanism. Dutch capacity providers must disconnect from the Dutch high voltage grid to qualify as direct foreign capacity for the Belgian capacity mechanisms. So what are the key takeaways on this review of the current status of capacity mechanisms? They address structural issues, they have long development times, they have regional impacts, and they can hinder climate and environmental goals. The question then is whether there is a mitigating strategy to these potential capacity mechanism problems. One question is what the demand side can do to the problem. Demand flexibility includes a wide range of technologies across industrial, transport, residential, and emerging sectors like data centers and battery factories. This diversity, along with technology advancements, can be a game changer, potentially, offering various ways to balance supply and demand. However, revenue streams for demand flexibility differ from production. For instance, there is no income during price spikes, requiring a different approach. Reliability options for demand flexibility need distinct management compared to production units, specifically regarding payback requirements. Additionally, the duration and activation times involving demand flexibility may differ from those from production units, since capacity mechanism markets are based on member states. Cross-border aggregation and integration presents a challenge. I believe that demand-side flexibility can significantly mitigate adequacy issues by reducing the need for additional generation. However, it often receives less emphasis in capacity mechanisms due to challenges in measurement, verification, and integration into existing market structure. If demand-side players were more active, cross-border issues might be less significant. Moreover, increased participation from demand-side resources could reduce the overall need for capacity, lessening the impact on capacity mechanisms on neighbouring markets. This could lead to a more balanced and efficient electricity market across borders. So with these considerations, my question as a final question from the presentation to the audience is, what do you think is missing to fully tap into the potential of demand-side resources to the system and to capacity mechanisms? So thank you very much for listening, and that was my presentation.